So first of all, thanks Kasam for organizing the trainings, and these sessions are there every weekend going on. And you already might have joined the previous ones, Azure Fundamental and Azure Active Directory fundamentals as such. So you must be having a fair understanding of how Azure looks and feels like, or maybe this is your first session, that's also fine. So this is the one where we are doing data fundamentals, and we will talk about everything in terms of data. So those who are thinking to work in field of data engineering, data science, data analytics, or already are working over there, then this is something which is of your interest as such. And okay, okay. So I just put my cell phone on silent. Now check this out. So what are we starting with? Before we start, let me quickly introduce myself. My name is Shivam Sharma, and Microsoft Azure is my primary cloud. I have been working on Azure since the starting itself. Since Azure was, we used to work on Azure old portal 2012 itself, and things were totally different. And on the way, the technology evolved, cloud evolved, Azure evolved, and data sort of exploded. So new fields were also generated, and earlier fields which were not that popular at that point in time, they also revived, and now we have new job profiles as well, and so on and so forth. So I work in Microsoft Azure. My day-to-day job profile includes consulting and training both. And I am also the co-founder of a company called as Tech Scalable. And we expertise in data, we expertise in Kubernetes, we expertise in cloud itself. So you can go and read about us. Now, what are we doing today? So we basically are working with, we are talking about Azure fundamentals today. And as terms of Azure fundamentals, everything which is there, the very first thing, or the very first thing which should come to your mind is, like when we talk about data, what type of data sets are there? We have structured data, unstructured data. Where do we store structured data? Where do we store unstructured data? What do we do with semi-structured data? In which scenario is structured used? How do we use semi-structured? What data? So this training is aligned with Azure, and we have one certification called as DP-900, Data Platform 900, which is fundamental certification from Microsoft Azure on data platform. So that is basically around 8 hours of training as such. However, we are having 2 hours of session, so we are sort of in percentage, we will be able to cover some percentage of the certification, but I'll give you overall idea of how to get started with data platform, how to get started with data itself. And we'll see some cool demos as well. And DP-900 certification is basically broken into these 4 modules: data concept, relational data, non-relational data, warehousing. So as part of these 4 concepts, if you cover, even if you're doing self-study or even in any ways around, you can go and clear the certification yourself as well. So these 4 areas is where you have to focus on. So data concept, roles and responsibilities, relational, non-relational data, data analytics, what's the meaning of it? Relational offerings of Azure, how to provision them, what are the various, how do you run queries against that? What are non-relational offerings in Azure? How do we provision, deploy these non-relational offerings? Components of modern data warehousing, data ingestion, how do we ingest data, streaming, when the stream is coming, how do we ingest the stream into Azure using some Kafka-based solution, or how do we work with, let's say data is on-premise or maybe in AWS, maybe in GCP, or maybe in your customer's Azure scenario solution, then how do you pick it up from there and you ingest into Azure and then you work with it? Building reports on top of it. So Power BI is Microsoft's reporting solution. So we can build reports with Power BI. So this is basically DP-900 agenda as well. And this is the line on which we will be also discussing our session. So let's get started. So check this out. Now the very first thing is, when we work with data, we basically have multiple job profiles as such. Let's say database administrator, data engineer, data analyst. So what are these job profiles? What do they do? How do they basically the various things which they are supposed to do as such. Now this over here in this slide, we have the overview. So in various companies, some plus minus may happen. However, database administrator will be responsible for database management, database security, backup access control, monitoring performance. Database engineer or data engineer will be responsible for pulling data from various locations, pipeline creation, how to run the Spark job. He should be aware of various offerings as such in the cloud itself, Hadoop-based offering, Spark-based offering, how to pull data from relational database, how to do a scoop job, how to schedule UZI pipeline, and anything to do with integration or pulling of data will be responsibility of data engineer. Data analyst will further then will provide the insights into data, visual reporting out of it, modeling data for analysis purpose, and he or she will be responsible for telling the stories, and with those stories, the data will be presented and will be of some business use case. So these are three roles in data field of data, which on a very high level will fall into database administrator, engineer, and analyst. So right now we are, so from point of view of Microsoft, we have various certification tracks are there. I'm pretty sure you guys are aware of the certification tracks, but on the way, I'll tell you more about them. So right now we are starting with the fundamental itself. So just give me 1 second. Let me quickly confirm something. So I have some demos with me ready. I'll show you the demos in some time. Just wanted to see all the things are running fine. Notice this. So the very first thing we start with is structured versus unstructured data. What is the meaning of it? In the world, most of the data is unstructured. Unstructured, and according to, so you can say around 80% of the data will be unstructured. And unstructured data is something which cannot be displayed in rows and columns, more like videos, images, or any maybe text file is there. So what is structured data? Something which can be represented into, which is having some schema, which can be represented into some sort of defined row column manner, and generally includes numbers, date, string, and around 20% of enterprise data will be structured. And according to Gartner, around 80% of enterprise data will be unstructured. Structured data requires less storage, and you might have been aware of relational databases such as SQL. Now, SQL databases are legacy solutions which are pretty useful, pretty good solutions for keeping the structured data. And once you write your data over there, the queries from these relational databases are very optimized and very fast as well. So where do we keep the unstructured data? We have little more problems when we talk about keeping unstructured data. So something you might have heard before is object storage, blob containers, or you might have heard about data lake scenarios. We'll talk about all of them going ahead. But we need these other type of solutions also to keep unstructured data. And once we have unstructured data, we will have data scientists and data engineers like you guys, and you will pick up that unstructured data, will process the data using various technologies in Microsoft Azure and or in open source world, and then you will give some business useful information out of it. So that's where we come into picture, and we'll be the key role factor. So you guys will be the key over there to process that unstructured data and do some machine learning AI with it. Now, let's further jump in. Check this out. So structured, unstructured is pretty straightforward as such. However, we have one more bifurcation called as semi-structured data. Now, semi-structured is, you might have seen JSON files before, JSON, XML files. Those files have somewhat structure over there, and they fall in the category of semi-structured. So the three categories of data will be structured, semi-structured, unstructured. Structured, something which can be put into table format. Semi-structured will be having some sort of JSON type of structure, somewhat such structure will be there. And unstructured will be images, videos, PDF file, and so on and so forth, which you cannot put, audio files also, which you cannot put in any type of table format. And we need to do processing before we can even pick up those files and do something with it. So three bifurcation will be like that: structured, semi-structured, unstructured. So I'm just repeating the same thing again. So structured will be looking something like this. and there are customer ID, customer name, phone number, and some numbers are there, names are there, and some phone numbers are masked as such. So data is stored in the table format itself. Rows, columns will be there, and each column will be having a definite data type, and all the rows will be having same number of columns also. Schema will be very tight, and we will have a defined schema, and we need relational databases to store some sort of structured data over there. And relational databases further will, like SQL, will further, we can do joins with them. We can have relationship across tables. And this is look and feel of how structured data will look like. What is semi-structured data? Semi-structured data can have multiple formats. You might have seen JSON format before or XML format. Apart from that, we also have Evro, ORC, Parquet. Parquet is something which is used a lot when we do data processing with Spark. One of the optimization on data is Parquet format conversion. So how does it look like? So JSON is something looking like that. And here I have one example where order ID is there. This is one JSON document, and ID of the document, some status of the document, category of the document, like book. Someone is purchasing a book. There is first name Claire Weber purchasing book, and so on and so forth. So the information which over here we have these properties and the values of them in key value format, and the data is stored in this format. So this is semi-structured type of data. Third is unstructured: audio, video, media streams, documents. Now, a lot of pre-processing is required before we can work with the unstructured data. So we generally convert this unstructured data into some numeric format, and we load them into tables. And then from using those tables, we then further do more processing on it. So the processing required to handle unstructured data. So what are we concerned about right now is that there are three types of data sets, and where do we store them in Azure? And this right now we are having a session which is aligned with Microsoft Azure DP-900 certification. So we are talking about offerings which Azure provides for us to work and store this data, and then how to further work with it. So one of the offering in terms of structured data is Azure SQL, and so in terms of Microsoft, if you go for infrastructure as service, we create virtual machines. So you guys must have seen you might be coming from the previous session of Azure Fundamentals. So virtual machine is just a virtual server, like in the cloud. Maybe Windows server is installed over there, Windows 2019, 2012, R2, or 2016, and you have installed your database over there. So when companies they move to cloud, if they are doing lift and shift, they go for infrastructure as service. So the same thing which they were doing on premise, they will do in the cloud itself, and they will take their databases with the VMs itself to the cloud and host them as IaaS solution, infrastructure as service. So that's the first offering. Now, once we start adopting the cloud, we further go into the right-hand side over here in terms of platform as service offerings. And in terms of PaaS solutions, Microsoft is having two solutions over there. One is called as Azure SQL Database. One is managed instances over there. Both of them are examples of PaaS solution, platform as service. So differentiation and so on and so forth. So from our point of view, we need to understand sort of when to use which one and what to go for in various scenarios like that. So if I tell you a little history about the SQL offerings which were there in Azure, in the starting, we used to have infrastructure as service, and we used to have Azure SQL database, and the middle one was not there. You can say around 4 to 5 years back, maybe I'm wrong by 1 year, but around 5 years back, we didn't have managed instances, 5-6 years back, and only these two were there. So when we used to go to the cloud platform, we had two options. Either we can lift and shift and we go for virtual machine approach, or we go for platform as service approach. But the catch over here is in the platform as service approach, full functionality of things, the way things were working on premise, full functionality was not there. Why it was not there? Because in the cloud, things are the same things are there, but way in which it works is different. So people were not able to do migration without any rewrite of application to PaaS solution. So for new application, PaaS solution was the go-to one. And if you have anything existing, you can take that to cloud in terms of infrastructure as service. So a lot of customers were giving feedback that we want to use something like platform as service, but we do not want to rewrite anything in the application point of view or from database point of view. So what can Microsoft provide? So Microsoft always listens to the feedback, and they released managed instances, which is more like hybrid between IaaS and PaaS. And this is the solution where full functionalities of infrastructure services supported, plus we don't have to manage OS just like it happens in uh, Azure SQL database. So people started migrating to managed instances, and this is very popular today. And also recommended that when you are going to cloud, you need to or think about going to managed instances directly. And if you're developing something new, you can go for Azure SQL database, which is also pretty big. We can have 100 terabytes of database over there. So huge databases can be there. So these are Azure SQL offerings. We will create Azure SQL database in the demo. So just hang in for that. Now this is one location where I will keep my structured data. I will have tables, and inside this I can keep my tables and I can work with that. Now, what do I do with my semi-structured data? Where do I keep it? Or what other offerings are there in Azure Cloud in terms of databases? Another very useful database is called as Cosmos database, which is basically over here. And let me do one thing. So before I go further, I'm just deploying this Azure SQL because anyways in the demo I have to show you. So I will just deploy one Azure SQL. Just hang in with me. We are deploying this one, the right one, and then we'll deploy Cosmos DB and so on and so forth on the way. Many things are planned for you. So the very first thing is I go to I find my Azure portal. So this is how Azure looks and feels like. So this is Azure look and feel like. And we are deploying one SQL server. So I'm clicking on this create a resource. And you can also search here. You can also click here. This is the same thing. From here also we can find Azure SQL. Literally it's there in the middle of the page. We can click on it, or on the top search bar also you can search for it. They all are the same thing. So it's literally written over there. I'm clicking on it. And okay, just give me 1 second. I think, okay. Just, okay, so let me just stop the slide. I think my laptop is not behaving very well. Now I think this is gonna be a little more smoother. Okay. Not really. Just give me 1 second, guys. So I think I have a lot of recording software and so on and so forth open, so the FPS sort of dropped, and the screen is getting stuck right now. So hopefully it will settle down. Check this out. So we'll deploy one SQL server, and what are we doing? I have some scenarios for you, and we'll create one table over there. And going ahead, we will do something with the table as well. We will load some data over there, and we will work with it. So just give me 1 second. Hang in. Okay, I think there is no issue with the internet, some normal glitch. Okay, check this out. Finally, okay. So we are creating one SQL database, and so the very first thing is resource group creation, which is just a group of resources. So I click on create new, and this is my first RG, and I'm creating one database. So this is let's say demo SQL database over here. Now it is asking me for server. What is this server? It's basically, so right now we are talking about platform as service. Now in platform as service, we have one concept called as logical server, meaning there is no VM over there, but there is still one boundary inside which the databases lies. So it's asking me to create that boundary over here. So this is my logical SQL server coming up. So just to randomize it, I'm putting my name over there. So the string becomes random and it is globally unique in that particular manner. So some username and password for login purpose afterwards. And as usual, the password doesn't match in the first time. So let's give it one more time. Location East US, I'm okay with it, or we can keep it somewhere nearby. I'm in Bangalore, India right now. So I just want to keep it nearby Southeast Asia, maybe. And how much, something like elastic pool resource sharing, not relevant right now. So over here, guys, when we create the SQL solutions, we basically have various options to select from here. Like how much CPU core do you want to give? Do you want to give? How much data do you want to keep? So this database right now can have 32 GB of data. And this is the cost it will cost me in the month end. We can also have SQL, which is totally serverless. So serverless SQL means that you will be paying for the storage and the compute will be on demand. So compute cost, if you're not using the SQL, will be bare minimum and the cost comes down. So right now I'm looking, it's just a demo. So I'm just looking for the smaller type of databases, 250 GB upper limit right now. We are okay with it. So I clicked on it. So this is my SQL database coming up and inside this server, and it will be in Southeast Asia. And what type of backup do I have? Locally redundant backup basically means so Microsoft is having 60 plus regions. You must have seen that in your fundamental Azure training, or you can say 2 weeks back, we did that on the weekend. So LRS is basically 3 copies of the backup in the same facility in the same region of Microsoft Azure. And I'm clicking on create and I just click on create. So SQL part is coming up, right? So once this is ready, we will come back to it and we will deploy some tables over there. And I have one scenario for you, which we will be configuring inside it. So in the meantime, let it deploy and let's come back to the slide deck. And let's carry on and let's talk about it. So structured data goes into SQL. That's one of the offerings. 3 offerings are there. And what happens if I have semi-structured data with me, then what do I do with it? One of the location where we can keep that is called as Cosmos database. Cosmos database is called as multimodal database because it is having multiple modes. And this is one location where we can keep our semi-structured data like JSON data. We also have graph database option over there. We also can have we can also store key value pairs as part of Cosmos DB. So this is called as multimodal. Why? Because we have multiple modes over there. So if I have on-premise MongoDB and I'm migrating that to cloud now, so I don't want to rewrite my application. So what I can do, I can make my Cosmos database with Mongo API, and I can migrate my data from MongoDB to Cosmos DB, and I can point my application to the Cosmos DB, and without any rewrite of the application, it will start working. The best thing about Cosmos DB is that it is distributed database. So when your customers are throughout the world, we use Cosmos database and multiple endpoints are there. You can see in this picture, which I snipped from Microsoft's website, that various endpoints are there and homing APIs are there. So homing API means that from the point of view of development, we don't specify which endpoint this application is pointing to. So if I have my databases in four part of the world, you don't specify which endpoint you point to. You just say, I want to point to Cosmos DB1 or whichever what's the name of your Cosmos DB. And the API call or the connection will establish to the nearest endpoint directly. So then we have various consistency level of data over there by which we make sure data also remain consistent. Meaning if you're updating some value in one endpoint, it should sync with other endpoints as well. So what is Cosmos DB? Non-relational, keeps one of the location where we keep semi-structured data, global in nature, multiple modes are there, pretty powerful, distributed in nature. So if you don't have a distributed application requirement, if you don't have a distributed database requirement, generally going for Cosmos DB might not be needed in that scenario. So this is Cosmos DB. And now one third thing, let me create this first, then I'll explain more about what is blob. So if you want to keep your unstructured data in Azure platform, what's the location to keep unstructured data? We have storage account blobs. We also have data lake. These two options are there. So let's deploy them and let's have a look at it. So I'm creating one storage account. And what is the storage account? 500 terabytes of object storage. Huge amount of data can be kept over there. So let's go and make one. Click on add and wait for it to load up. Resource group, the same we just selected first RG. Let's select that. And this is the first storage account. So let's give it the same name, first storage account. And it's saying that the name has already been taken by someone in the world. So just to randomize it, I'm putting one random number over there. So now the name is available. And the location, it is saying Southeast Asia, which is all good. SSD is standard. SSD is premium, HDD is standard. Other things are not relevant right now. If this is something which we covered in as part of fundamental of Azure. So I'm just creating one storage account. I'm just clicking on create, and I'm just clicking on create once the validation is passed. So what is this coming up? This is called as storage account in Microsoft. 500 terabytes of data can be kept over there. Multiple type of services will be available inside it. And it's one of the go-to location to keep your unstructured data in Microsoft Azure will be storage account. Now there is one more thing. In the meantime, it comes up. I just want to deploy one more scenario. I'm clicking back on my storage account option and I click on add again over here. And then this time I select the same resource group, no change as such. But this time I'm creating data lake. So I'm just naming it properly. So afterwards we can understand which is data lake and which is not. So this is data lake and the name is not available. So let's randomize it, one random string. And this got created. So Southeast Asia and other things as well. And notice this. So to create a data lake, I click on this advanced section. What is data lake? Why do we use it? Just hang in for 2 minutes. Check how to make it. Then I'll just explain that part. So on the basic section, I just filled up the same form, no other change. And I'm going to the advanced setting. And in the advanced setting, I am clicking on my data lake and I'm just saying enable over here, right? So this just got enabled. And like this. So what did we do? Let's understand that what these two things we did and what's the meaning of that. So the very first thing we deployed was one storage account. The storage account was having 500 terabytes of upper limit, right? Like that. Example of object storage. Now, when we work with big data, let's say you have Spark and Hadoop, and you are working with a huge amount of data, we need big data tools to process that data. Now, big data tools, they read from Hadoop file system. So this over here, this is Hadoop distributed file system from where data will exist, and these big data tools will read from it, will do the processing over here, and will write the output back, or maybe in some other location like that. So in Azure, data lake is that location which is 100% compatible with the HDFS. So if this is my big data tool, let's say big data tool like Spark, then this location from where I'm reading my data is Azure Data Lake over here. This is data lake. Now, what is this data lake? This is 100% compatible with the HDFS. And there is no upper limit of data lake, meaning you can keep as much amount of data as you want. You petabytes and petabytes and petabytes and petabytes keep on throwing. Microsoft will keep on, Azure will keep on scaling it. So no upper limit as such. So these two solutions are there. Whenever we do analytics, we select data lake. Only then we require it. When we don't do analytics, we just want to store unstructured data. Storage account is the location you will keep it, and it is having 500 terabytes of upper limit. Is data lake having any upper limit? No, this is not having upper limit. There is no upper limit over there. So no upper limit of data lake. So, but when do we use it? When we do big data analytics, data lake comes into picture. If you are not doing data lake analytics, so if you're not doing analytics itself, if you're not working with big data, you don't have Spark, Hadoop, or any other tools as such for process your big amount of data, you generally might not go for it. Why? Because the cost is one of the factor. Unnecessary payment doesn't make sense. So this is storage account on the left hand side. And I just showed you how to deploy both of them. And by now they both are up. Let's load some data into this storage account and have a look at it. So I just want to go back to this option over here, storage account option. And I have two things right now on the screen. This is normal storage account, and that's a data lake. So what is data lake? Now, in every company, we don't throw data anymore. Data is pretty important. Maybe even if we don't know what to do with the data, we still keep it. Like in future, you guys will be there.
Sir, hello.
You will be data engineers and data scientists as such. Any question? I heard something. So we don't throw data anymore. We will just keep the data with us, and we need some location which is a huge where we can keep that much of data. So the option will be data lake in Azure. So I'm going to my storage account, and I just want to upload some data over there. So I can show you one demo in 2-3 minutes.
We cannot hear you. Someone we muted.
Oh, I think somebody muted me also. So check this out now. Please don't mute me. And notice this. So what I'm doing right now, I'm uploading some data in my storage account and over here, and we will do something with the data. So storage account is ready, and I clicked on it, and I clicked on the overview section over there, and I click on the container option. And these are 4 type of options which storage account provides. Containers are blob containers, object store. File share is SMB file share, like a shared folder. Tables are key value pair, and it's no schema, non-relational tables, key value, partitioning possible, indexing possible, and pretty scalable, pretty cheap. Queues are queues, message passing mechanism, queues as such. So I'm uploading some data over here. I'm going to my container section, and I'm just making one container over there, which is called as ADF tutorial because of some reason. I'm just giving this name. I'll explain what I'm doing. So this is my container, and my data in storage account will be inside these containers. These are blob containers. So the data now will be there in the blobs. So that was just like a grouping of blobs together. So I have one file with me that I want to use, want to push it over there, and it's somewhere in my desktop. So just looking for it. Give me 1 second. Okay, so this is the file which I have. A simple comma separated value as such, and simple txt file. I'm uploading this file into a storage account. The purpose of it we'll come to know. I'm just uploading this. This is how you look and feel with this is how you work with Azure, and you basically click and you work with it. So this is that file, and it is now uploaded over here. So this is storage account as such, and let me just come back over here. So now guys, one thing which I want to explain. Now when you upload the file into storage account, there are a couple of things you need to remember. So if I go back and show you, I just default uploaded that. So if I click on this advanced option, we have many more options over there. Like we have blob, page blob, append blob, like this. So in various scenarios, various options are selected. So block blobs are having parallel upload functionality and sequential read or stream of data. So whenever you want to do parallel upload and sequential read, we use block blob. Page blob is random read and write. So if I want to have a storage location, and from the storage location I want to do random read and write, then I will be selecting page blob. Append blob is for append operation. There, you can say when we write the log files, append only operations are going on. So that is used in that scenario. So various type of binary large objects are there, and these binary large objects are something where data is stored. So I'm pretty sure that you guys are experts in object storage, but just for my peace of mind, I just want to invest 1 minute into it. So what I did, I went to my storage account. Over there, I created one container. Inside this container, I uploaded that txt file. So what happened behind the scenes is literally there is one location called as object store. So this is that storage location, object storage. So inside that, I created this container over there, which looked something like this. And the name of my container was ADF tutorial, like this. And then inside that, I basically uploaded the txt file. So in object storage, data is stored in this format. There is URI of the object, metadata of the object, metadata, and then this is the blob. So here is blob. So binary large object. And my txt file was actually this file over here. This is my data. So this is where we store, this is how that looks like behind the scenes. This is that .txt file, which I uploaded in that. And this is called as one object, like that, one object. So like this, if I upload more pictures or more things, everything goes into blob. So URI will be there, metadata will be there of the data, and literally data itself will be in blob. So imagine if I upload maybe a CSV file, then the CSV file is actually this. And where is it uploaded? It's uploaded in the blob as such. So data in object storage is always in blobs. What is blob? Binary large object. Various type of blobs are there for various use cases. So this is right now this EMP, the employee.txt file is actually this file in the blob in object storage account inside one container called as ADF tutorial. Just collection of, you can say in simple words, container is just like collection of these blobs together. Right now, we are not talking about Docker containers. This is normal blob container. So this is what happened behind the scenes. Now, as we are discussing, there are various type of blobs. So these are various type over here. Now, blob has maximum size of 4.7 terabytes. This is not exactly correct. This slide deck is from Microsoft, but they have recently released one more. It's in preview right now in blob, and the biggest file size is now around 175 terabytes. It's not 4.7 terabyte. Now the biggest size I can put in one blob is 1.75 195 terabytes. 195. I may be wrong by maybe 1 TB, but it's around in that range. 195 terabytes. Huge file can be kept. Very useful for big data. It's in preview right now, the bigger file size. And individual blocks can have 100 MB of data, and other sizes are there. Some more technical words are there, 50,000 blocks and so on and so forth. Page blob can have 8 terabytes of data, 5 and 2 bytes pages are there. We keep virtual machine disk over there. Append blobs are 195 GB in size. You don't have to remember all the details as such. You just need to remember that blobs are there, and there are type of blobs, and there are use cases around that type of blob. And if when you study for the certification, go into little more detail into where do we use it, why do we use it, and this is basically parallel upload, sequential read, random read and write is page blob, append blob will be append operation, to append over there. Now, coming over to data lake, we have if you need Hadoop file system, Hadoop distributed file system, then data lake is that HDFS location from where any big data solution can read. So big data solution in Microsoft can be in terms of Spark-based cluster or Hadoop-based cluster, or even Kafka, and many more type of clusters are there, interactive edge-based cluster, and so on and so forth. So they store their data in data lake. Generic concept is we will not throw data anymore. We'll store it. We'll have data scientists like you. You guys will one day drive some information out of it. And this is how it looks like. Now, there is one more thing called as data ingestion. When we work with data, one of the very key thing is how will you get your data? My data is on-premise in SQL Server. My data is in SAP HANA on-premise. My data is in S3 bucket in AWS. It's in GCP, or it's in my client's Azure subscription. Or maybe we have mobile application from where data is coming as a stream right now. So all this various type of data, we want to first ingest into the cloud. Then only we can do something with it. So one of the go-to solution for ingestion of data in Azure in terms of batch ingestion is called as Data Factory. What is Data Factory? You might have heard about ETL before. ETL is basically extract, transform, and load. So we extract data from source, we transform, and we load into the sink over there. And when we do the ETL transformation, some basic filtering will be done in middle over there on the data. So in Azure, ETL is exactly not ETL. We do ELT over there. And ELT stands for extract, load, and then transform. So what's the difference between ELT and ETL? Now in ELT, the level of processing which you are doing will be very, you can say very advanced. You can do complex processing. And in ETL processes, that complex processing is not possible because data is in the middle in some server, which is having some X amount of compute available and RAM. So that level of processing is limited by the server's capacity of performing the transformations. So in Azure, we have ELT, and I'm just showing you what's the meaning of it. So this is my exact demo. Check this out. So what do I have with me? We have the storage account in which we uploaded the EMP employee.txt file. And what are we going to do? We are going to make one ingestion pipeline now, and using Data Factory. And I'll explain more what is this copy activity and so on and so forth. Our SQL server is also ready. By now it is ready, but we don't have the table over there. So what are we going to do? We have already done this part. Our storage account is ready with us and data is already there. Our SQL is ready, but table is not there. So we have to deploy that table over there. So for that, couple of steps you will see me do right now. And then we will go and we will deploy the Data Factory. And this Data Factory is basically ingestion service. And we are going to do extract and load. So extract part and load part. So in ELT, we are doing E and L right now. T part, I'll explain what's the meaning of it and how will you do it. But E and L is something which I'm showing you in this point in time. So let's do the requirements. So basically storage account is ready. Let's deploy this Data Factory. It will take around 1 minute for it to come up. In the meantime, we'll go and deploy the SQL, the table in SQL over there. Then we'll make these red connections. We'll talk about them and we'll do the extract and load part. Now this location does not need to be in cloud. In the demo, it will be in cloud. Right now, it is in Azure cloud itself. This location can be anywhere. In any other cloud also. It can be on-premise also. Just needs to be resolved. Like you should be able to read data from it. So let's do it. So I'm deploying this gray part right now, Data Factory part. This gray part over here. Check this out. So now even so this is something which is in every company. So now if you have worked with if I use some terms and it might recall you. If you have worked with SSIS on premise, this is SSIS in cloud. If you have seen Uzi, this is equivalent of Uzi. If you know what is Airflow, this is equivalent of Airflow, right? Or just note those terms down, or just have a look over here. So I'm creating my first RG. In the first RG region, let's go for Southeast Asia where other things are there. So name is my first ELT pipeline. So that. So the name, let's see if the name is available. Okay, no, not available. So randomize it. This is available, my first ELT pipeline. And version, don't worry about versions right now. It's asking us to connect with GitHub or Azure DevOps. I have not configured anything, so Git configuration later. And review, create. And let's just click on create one more time. This is create again. So data factory is coming up. This gray, we will configure the rest of it. Let's deploy the table in the meantime in SQL. Let's do that. In the meantime, it comes up because it will take around 1 minute for it to be ready. And it's already done. But in that point in time, we need to have the data with us, the table with us. And we are going to extract data from here and we're going to load over there. That's what we are going to do with the help of one pipeline. So I'm going to my SQL server, SQL database right now. Now SQL is having firewall setting. You see this firewall. So I have to whitelist my IP address over there. Otherwise, it will not let me query this database. So I go to the firewall setting. I say add client IP. It adds my public IP address over there. Automatically, it detects it. It adds it. So and I'm saying allow Azure service. Yes. What's the purpose of it? I'll explain once we reach that part. I'm just clicking there, yes, and I save it. So what I'm doing right now, this I have this gray color logical server. I have this blue color database with me, but table is not there. Table I need to create. So I want to create the table. I want to run one query to create it. But there is a firewall which is protecting this server right now. So I whitelisted my laptop. So in this step, what I did, this is my laptop right now, and I whitelisted my IP over there in the, you can say over there. So this is my client IP is basically my public IP address of my internet service provider. So that is whitelisted. So now I can have tools such as SSMS, or I can have, you can say another thing, query editor, by which I will run some queries over there. So whitelisting is what I did just now, this green part. So I can do the next part. So check this out. Now let's make the table over there. So we can do some ELT. And I'm looking for query editor. So what is this query editor? This is, it's a browser-based management tool by which I can run queries against database. And the moment of truth, whether I remember the password or not. So otherwise, I will show you how to reset it. And luckily, I remember it. So check this out. Now, so let's make it slightly bigger. OK, so what I'm doing right now is this part. I'm creating the table over there, right? This the table with 2 columns. So I'm just looking for the query. I had it. So I have a secondary screen. I already wrote it down. So let me just quickly see where is it. OK, found it. So creating one table, first name and last name, you basically 2 columns will be there. And let's make it table done. So this is my table right now ready. It's empty. We will load some data. So you can see that there is nothing, there is no result. It's totally empty over there. And now this part is ready. And we are going to load the data from the from this txt file over there. So the concept right now is that the data might be coming into this storage location from any other production endpoint, and data is non-stop coming over here. Or this may be on-premise. It might maybe your ERP system, or maybe SAP HANA or warehouse or something on-premise from where data is continuously coming from any other location. Now you want to pick up the data from there and you want to get it to the cloud, and then further transformation can be done on top of it. So data factory will do that particular thing for us. So we are doing this gray part now. And so let's not close this. Let's open in a new browser. So we'll come back. We'll run the query once it is successful. And So basically, data factory name was something like first RG, and data factory is this one, first ETL pipeline and random number. And I click on the author section, and it is having a different GUI over there by which we will configure the thing. So this opens like this, and I click on author, and I'm creating one pipeline over there. This is my new pipeline. Pipeline one is name is good enough for me. Pipeline one, like that. So now what do we do over here? Now, right now I'm just showing you copy, but there are many more type of activities which are there. What are these activities is something which I'm dropping right now on the screen. So let's say if I was working with Hive or Spark, or I was getting my data from various location, I can connect these activities together, and in one pipeline they will execute. So in our companies, we want to do that. We don't want to do manual tasks. If you have any 200-step pipeline, it's 200 steps in your data transformation pipeline. It's better you configure that in data factory pipeline and let it run on schedule. So every day it might run, every 2 days it might run, or you can also trigger it remotely if you don't want to run it on a schedule. So it will trigger in that manner. So right now we're just copying data from source to sink. So check this out. And copy is always from source to sink. If you think it through, like this is my source of data, and that's my sink of data, right? Now source can be anywhere, right? But like that, sink is right now in Azure Cloud. So you see this red line over here. This red line is just the connection configuration. So source and sink. So some connection strings you will see me do now. So let's do it. So I'm going to the source part, and I'm clicking on new. So the answer of the question that what other sources are possible is this. I can pull my data from Amazon Web Services, Marketplace Web Service, Redshift, Amazon S3, Impala, storage account. This is what I will select afterwards. Blob, I can get my data from. In Azure, most of the things are supported. Postgres SQL is also there. Azure SQL is our sink. We'll select it afterwards. Cassandra, Couchbase, Drill, FTP location, Google as such, HBase, HDFS, and so on and so forth. So these are all the locations from where you can get your data. If you have data which is available over REST endpoint, we can read it from there as well. Or SAP solutions are also supported, and so on and so forth. So right now we are looking for, as per our diagram, the location source is storage account. So we will select the same thing, and let's do it. It was called as blob storage, this one. Let's say continue. And what file format are we reading? Are we reading XML right now? Parquet, Excel, JSON, ORC, Abro, binary. We are reading a TXT file, CSV, comma separated value as such. So I click on it, and I'm basically continue. And it is asking me for some connection strings and so on and so forth. So I click on this linked service. I say new. So what is this part? This is this red part where we are doing the connection configuration between the various solutions. So, okay, my subscription storage account is called as first storage account. This one, that's where our data is, this one. And that's all. Just test the connection for the sake of testing it. Does it establish or not? Perfect. Click on create. So what I just did, I sort of did this red part. Now it is asking me, Shivam, that you have such a big location. Which file do you want to read right now? Do you want to read the entire thing or some particular thing over there? So right now I want to read one file over there, which is called as employee.txt file, which we uploaded in a couple of steps back. We literally uploaded that. So this is that container. This is a txt file, and just select OK. Now it is asking me that is the first row as header over there? Yeah, that's literally the first row is header. What is the meaning of it? Let me, I think I have it open somewhere in my secondary screen. Let me show you. I hope you got it. The first row is header, column names like that. So that's what we are giving. The schema is literally the header, first row is header. So column names are there. So keep it like that. Now we just say OK. So what it will do, it will do this red part. So the copy activity, the connection part is done. And sync part we have to do now, right? So let's quickly do it. So I go to the sync part, and in the sync I just say new, and my sync is SQL. So not MySQL, SQL database, and click on continue. And same thing, just say next over there. And now this is my sync location. From data will come from source and will go in sync. So server name, that's the only server name coming up. So I think that's the correct one. Demo SQL database, yeah, that's the name we gave. And username and password of the database. So over here. Now, if I test the connection, so, okay, I think the password is wrong. So let me give the password again. Okay, perfect. So now SQL was behind firewall. So because SQL was behind firewall, it's the reason when I was doing the firewall whitelisting, I added allow Azure services. So the Azure services got whitelisted, and that's why the connection was established. So there was one yes and no a couple of steps back. I told you that I will tell you what that means. That's the meaning of that is basically I wanted the data factory to talk to my SQL. If I would have not allowed Azure services, it would have not made this connection. Or I might have then told you about networking, which we can avoid right now. So now table name of the table, okay, is literally db.emp, and that's all. Let's just run it. So what are we going to do now? We will trigger this. Now, when you run this, you can run this on a schedule, manually trigger it, or you can say callback URLs are there. If you trigger the URL, it will run the pipeline. So event-based triggers are also there. So right now I'm manually triggering it, and basically my data will copy from there to there. This is one-time copy. If I want, I can also do incremental copy. Like I just have to hold my flag somewhere, but then I can do incremental copy. So only data which is of today or the data which is delta will be copied from source to sync. Everything is configured. There is no limitation as such of data factory. Pretty good solution. So let's do it. And this is trigger and trigger now. Oh, sorry. You have to publish the code first, right? I didn't publish it. So I'm validating whether I made any configuration mistake or not. So everything looks OK. And I publish my code. Publish the code is basically like save it or publish it like commit it. And then it will trigger after that. So it told me that there is no code which is published. Please do it. So we did it. And let's trigger now. So it's saying no parameters. That's fine, because there is no runtime parameters which we are giving. And let's wait for it to trigger. Now, when we work with these pipelines, you can go to the monitoring section. You can monitor what is going on. Just click over here, and it will tell you what is running, what is not running. And it's a very small pipeline, so it already succeeded. Otherwise, we would have seen over here, like step by step. Like if there were many 20, 30 steps, it would have told you. Step 1 is going on. Step 2 took 5 minutes. Step 3 took 3 minutes. Step 4 took 12 minutes. Step 5, this is going on. And overall pipeline. So it is literally saying 2 rows written. Let's go and check it out, whether 2 rows are written or not. So SQL is over here. Let's run this query now. So this is the 2 rows which we pulled from the source and we have written in the sync over here. So this, what I just showed you was one example of extract and load. Now, once my data is in Azure cloud, so data came into over this in Azure cloud. It's not always supposed to go in SQL. This was just one example of how to do it. Now, then comes into picture the big data part of it. So let's say the transformation part of it. So in ELT, we have the T part of it, right? So this is the T part of it. Now in Microsoft Azure, we have various solutions by which we can create the big data cluster. So one of them is called as basically HD Insight, and the other solution is called as Databricks, Azure Databricks. So by using these solutions, we can create the big data clusters over there. Databricks is Spark cluster. HD Insight can do 7 type of clusters. One of them is Spark cluster, and one of them is Hadoop cluster. and Kafka and HBase and so on and so forth. Other type of clusters are there, not relevant, just FYI, sort of, if you know it, then those other options are also there. So let's say I want to drop, you can say one Spark activity over here, and that Spark is this cluster. Now we can create the cluster on demand as well. And we can also, this is on demand, or we can also do it in terms of, it can pre-exist also. Like it's not getting created on demand, it pre-exists as such. And data can be pulled from this location and it loads over there. And there we run the jobs. This is where job is run. What are these jobs? Basically, job can be Python job, can be Scala job, or can be Java job. So the piece of code, and this is where you will do the transformation like that. So what do we have? We have E, L, and T part of it. So all of them in one example like that. So think it through. Any question which comes to mind, please ask. You can use the chat window as well. And let's go back to the slide deck and let's see it. So this is what I showed you, extract and load. Transform part was not exactly, let me just quickly show you. I don't have any transformation, you can say logic built on top of it, but how to connect both of them and so on and so forth, that part I can still show you. So notice this, and we still have time. So have to utilize the time somehow. So my copy of data got finished, and let me search for data bricks. So, okay, let's say.
Shivam, I just had one question regarding data factory. So why do we always do an ELT flow rather than doing an ETL flow in this?
Now see, now practically, let me thanks for the question, and check this out. So let's say my data was coming from on-premise. Imagine this is my data and it is coming from on-premise. Let's move them, or let's delete them so we can have some data. Let's say over here like this. So maybe this is AWS over here, and let's say this is on-premises over here. So two scenarios, let's say on-premises or maybe AWS. So see, now if I'm getting my data from AWS, let's say this is S3 bucket in AWS and I have some data over there. So if you're getting your data from that location, so if we think about this, the extract happens over here. This is extract. Secondly, this over here is the load happening. So magically on the internet, it is not possible to transform like that. And even if we want to transform using any tool, that it takes time to do the transformation. So if you have very complicated queries which you want to run, then you will go for ELNT afterwards, transformation with big data or any other tools like that. If you have some basic filtering, basic transformation, or something very sort of just data drift mapping and so on and so forth, then maybe not with data factory, but maybe with any other tool you can do extract, transform, and load. But those transformations may not be as complicated as what we can perform with EL and T part, because we load the data into the staging location, and from the staging location we pick it up, further transform it, and we work with it. So there is no magic over here, because on the internet I will not be able to run my Spark queries. So I load it into cloud and then I further do with it. Similarly from on-premise also. From here also, let's right. So check this out. So let's say I have this SAP system on-premise, and let's say some firewall is there. This is firewall, and like this. So some server will extract the data. This is extract. It's also part of data factory offering these on-premise agents. You see these agents are there. These agents are basically extracting my data, and they will also load the data into the sink over there. So let's say load part, and then we will transform it. So because of these reasons, ELNT is more useful now when we work with big amount of data, and ETL is not going anywhere. Everything is there like this.
Okay, so basically the on-prem ETL that we use has some buffer the memory to do the transformation in the pipeline itself. But here we don't have that thing, so we first load and then do the transformation.
Correct.
Okay.
That's absolutely correct. And if I go for Spark cluster, on every node we can have a huge amount of RAM. So this is different. The real-time processing can be done with big data Spark type of solutions. So check this out. So what were we doing? I was dropping that data factory part over here. I have not done this data bricks creation. I'll just quickly create that. So let's find Azure portal and let me make data bricks. So this basically I was not I was expecting my presentation to go a little more longer, but I think I miscalculated. So I'm just showing you some extra things now. And let's deploy this in Southeast Asia. And Databricks is my first Spark cluster. Spark cluster over there. And pricing tier as free as possible. So maybe this is also fine right now. So this is my Databricks coming up. It will come up in 2 minutes. So what is this? This is this box over there, the gray part. This gray part is basically what we are doing right now. And then we will create one small cluster over there. This is one small cluster. And this is the cluster over here. And then I'll show you some connectivity strings and so on and so forth. And how to make the notebook, what type of notebooks are there, and just look and feel of it. So how does it all connect together and so on and so forth. So in the meantime, that is coming up. Yes.
Hello.
If you have, do you have any plans to cover about preparing for fundamentals exam by end of the presentation? Do you intend to do that also?
So in the what type of questions are coming, and so what we have done after the end of the presentation, we basically have one you can say quiz created for everyone, which I think will go on the mail or maybe in the chat window. I'm not aware of it, but that questions will be there which are aligned with the certification. And 2 of you lucky winners are getting the voucher also for examination, and you can go for it. And basically all of this is asked what we are discussing right now in that examination as well, and in the certification also, and in the quiz as well. So whatever questions you have, guys, please keep on asking them. Right.
So one question. So with respect to the data, we extracted, we actually stored the data in the blob, right? That is emp.txt was stored in the blob storage. And from there, we used data factory to push it to the SQL database, correct?
Correct.
Yeah, so my doubt is this the only way that we can extract data from the blob storage and put it into the SQL, or what is the significance of using data factory here? Can we do this without data factory also? Is it possible?
See, simple copy, let's say loading of data from storage account into SQL can be done by one more solution called as Polybase. Data factory will be useful when I have multiple steps in the pipeline. So let's say step 1, step 2, step 3, step 4, 200 step pipeline. So then doing those manual tasks, we will just automate with one pipeline. That's where the significance of data factory will come into picture. Not only copy, but more things also.
Correct. Not only not only for copy, data factory will not have that much significance. But if we want to do some multiple steps, then we will create a pipeline, and in that scenario, it will be very useful, right?
Absolutely correct.
Okay. And for just for taking the data and loading, I can use something called Poly. That is what you are.
Polybase. Polybase is just it's one. So in SQL, in Azure or on-premise also, we have one utility called as Polybase utility. Polybase utility can be used to extract my data from various locations like object storage or HDFS and load into SQL solutions. So Polybase can.
One question, sir. So can I use any REST APIs provided by Azure to code it and load the data, to just load the data programmatically?
Yes, we can use .NET SDKs there. So basically, the piece of the .NET, the program which you have will load data into SQL. It will read from storage, will write into SQL. Can be done.
That is possible, right? Okay.
Yes.
Thank you. Sir. Yeah.
Right. Okay. So guys, let's see this. Data factory is coming. Yeah, go ahead.
Yeah, I just want to know what is the difference between data brick and data lake?
Okay. So data lake and data brick. Okay. Check this out. So this is data brick, Azure data bricks, and this is the Spark cluster. So big data Spark cluster over there. So this Spark cluster will read and writes from somewhere. So over here is data lake. So data lake is storage location. So this is data lake, Azure data lake storage location. And over here, the data will be kept as such. And from here, read write will happen. And basically like this. So this is equal to HDFS, Hadoop Distributed File System, like this. And the compute is over here. This is compute part. Got it right? Compute and storage. Compute part, this is storage part.
Oh, got it. So Databricks is the compute part and data lake is the like is top on that storage part, right?
Will be the storage part.
Okay, thank you.
So even the transformation is also been taken into the Databricks.
Yes, check this out.
All the computing. Okay.
Yes. So compute will be just the compute part. I just mean the transformation will require some compute to do it. So this is where the transformation will run. So the Databricks looks like that. We come here, we create clusters. So we click on cluster and we click on, let's say create cluster, and let's create one cluster. So this is my cluster one, Spark cluster. And don't worry about other details, not much relevant, going a little advanced, but I'm just making one cluster and one node, mine, it's just a demo. So making a small cluster, you can make 50, 100 node clusters as well. So this is my cluster coming up. So what I just did, I made this green cluster over there. So now the next part is the job part. So the code goes in this job over here. This is where the code goes. So where do I and how do we make this code? We basically click on this workspace. You see this workspace, click on it. And from here, let's say create notebooks. What type of notebooks do you want to create? Is it Python oriented job, Scala, SQL, R, and so on and so forth. So select the one which you want to create. And this is first notebook and just click on create. And this is where your code goes into picture.
This is similar to Jupyter Notebook, right?
This is exactly similar to Jupyter.
Okay.
Absolutely correct. Right. So this is where your code goes into picture like that. So, and then we can manually trigger this also, but right now we are thinking of doing everything from data factory. So you may have 10, 20, 100 step pipeline in which data is getting copied from multiple location, going into staging, then transformation, then putting into some analysis services where data cubes are getting created, and then reporting and so on and so forth. So full pipeline end to end can be designed with data factory.
Okay. Hey, one question on transformation. Is there any GUI or some drag and drop facility, or is it always dependent on IT? Is there like some power business users or some data scientists can use some GUI to transform?
Now, okay, that's very good question, and Microsoft answered it already. So yes, that is there. Just give me 1 second. So normally, if I don't use GUI, I will write my Python code over here in this notebook in Spark. If I use Databricks, then this is purple color is my notebook. This green color cluster is coming up, and data will be wherever your data is, will be present over there. Now, we connect both of them. Some extra steps are there. We just click here and there, some user settings. We generate some tokens and so on and so forth. This is just for my demo purpose. And I click some generate and make sure you copy the code. So I copy it. I just go back to my data factory. I connect both of them. I click on it. And Let me just think it through. So new, okay, access token and so on and so forth. 1 second. So give me 1 second. Yeah, any question, please ask. Okay. So basically, okay, Databricks workspace works Spark cluster. Databricks URL already coming up. Access token I copied. I'm pasting it. Cluster may not be ready by now. So use existing cluster. And let's load it one more time. Oh yeah, sorry. It's not showing yet. It's getting created. So the cluster is still coming up. Okay, so once this cluster is come up and so on and so forth, so then what do? We just go to our data factory back again and we finish this configuration, and you come back to the author part and your pipeline is ready now. This is two-step pipeline where data will get copied and one transformation will happen and the notebook will run in Databricks in that Spark cluster, and this is two-step. Similarly, we can have 20 200-step pipelines, and this is very common in every company. You will use, if you are in Azure with Data Factory, you will create your pipelines. Manual tasks we will try to avoid as such. So once we run this, two-step pipeline will run. Now the other question, can I do this from the GUI also? Yes, we can do that. This is called as data flow. So if I drop this data flow, I say data flow, and I click on OK. And now this is GUI. So it is asking me that add source of your data. So this is GUI. So same thing which we can do from Python, you can do it from here as well. And you can select your input data wherever that is, and you can drop your transformations on top of it. So I want to join data, or I want to aggregate data. I want to select some rows and columns from it. So let's say I want to drop some columns. I want to, so this last name column, I want to make it as last name new over there. So any transformation or any movement or any dropping of data and so on and so forth, it's on GUI also possible. So this is part of data flow over there. That's your answer.
Oh,
so both
thanks. And we have seen like data flow also exists in the Power BI, right? That's the web-based Power Query kind of thing. Is this something similar, but at a very high scale level?
Yes, this is similar. But and where is this running? So if I create this pipeline over here, let's say if I create this GUI-based transformational pipeline, but when we run this, this also runs on Spark. So on demand, they will create one Spark cluster behind the scenes. And let's say there is data flow. And this will run on the Spark cluster behind the scenes. So on demand Spark will be there. So everything is running on Spark. Maybe you do it from Databricks or it happens automatically from GUI. But transformations are going in the Spark as such. Think it through.
Okay, thanks. Hey, one more question. Can you share some information regarding the Azure Synapse? Is this all this package of loading, ELT, and on top of that analytics, Power BI is all getting captured into a Synapse as a platform?
Check this out. Now, when we talk about data processing, we are just coming to it. So before we go there, what is HD Insight? HD Insight is where we have big data clusters. Now I can create Hadoop cluster over there. Hive, I can have H-based cluster, Storm cluster, various type of big data clusters in Azure is all together called as HD Insight. So where will I make my big data cluster as part of Databricks or HD Insight? These two options are there. After that, we come to warehousing. So when we create the warehouse in Azure, the name of the warehouse is called as Synapse. Earlier, it was called as Azure SQL data warehouse. Now it got renamed, and this is called as Synapse over there. And yes, they have combined lots and lots of Spark-oriented computation on Synapse, and it is pretty fast. So as part of my warehousing, I first need to get my data. So one of the things by which I can get my data is Data Factory. I can get my data from Databricks. I can do the data transformation with Databricks. And also one more thing I can do is basically, if my data is coming as a stream, So scenario like this, check this out. So let's say data is coming as a stream right now. We have these IoT devices and so on and so forth. From here, data is coming as the stream, and we can create Kafka clusters over here. So Kafka clusters are basically publisher subscriber model, and this is my Kafka cluster. So as part of HD Insight, I can create this ingestion layer solution. So for stream analytics, and inside this, we will have some sort of thing called as a topic. Don't worry about that, but basically the data is going inside this. So when the data is coming in, so this is the publisher of data, and this is Kafka, and data URLs are there. Data is written inside the Kafka cluster, and then consumer will be there behind it. So imagine behind this is where my Spark cluster is there, Databricks or HD Insight Spark, and on real stream of data comes and it goes, you can say as a stream over here in Spark, and this is where your notebook is running, or your Python job is running, or your jar file is running with your code, and this is Spark. So we stream data in, and runs on literally window of data, like 5 seconds, 1 minute, based on how much we want. And this is my output, and the output can be visualized directly as well. This is visualized over here, so maybe Power BI, or you may after transformation store it. So when you store the data, one of the analytical storage location is called as warehouse, where you can store that structured data. So this is warehouse. In a very simple words, warehouse is having 60 storage location nodes over there. And inside these 60 storage node is where my data is kept. This structured location is called as SQL data warehouse, and which is literally now called as Synapse, Azure Synapse. So it does not matter how I'm getting my data. You may be having some sort of streaming solution over there, and with the streaming solution, you are getting your data. So we can create the Kafka cluster ourselves, or we can create this blue thing. This blue thing is basically Microsoft offering on top of Kafka, called as Event Hub, IoT Hub. So we can also create them, and with which we can have the stream of data coming in. So these are IoT Hub and Event Hub, so which are built on top of Kafka for streaming scenario. If I want to do my batch analytics, how do I do it? Maybe my data is coming from AWS, let's say like this, and we have data factory, ADF. So ADF will, let's say, extract and needs some loading location. So let's say this is data lake, and this is the HDFS storage data lake location. It loads data over there, and then the transformation is happening over there with the help of your notebooks. So transform. So in one example, I have streaming combined with you can say batch analytics. Think it through. Any question comes to mind?
Shivam, just one question. This is okay when we say we have structured data out of transformation, and then not structure, but the analysis part that we have performed and published it to Power BI for a reporting. What if a multidimensional system, like we expect the data in multidimensional form, and then we want to publish that into Power BI? So where we can store that data?
Now that's a very good question. So I was I'm sort of avoiding a lot of things just to keep this within 2 hours, but I have no issue answering your questions. So this is Power BI. Now, when we work with, let's say, multidimensional data, we have one serving layer here. So this is a serving layer. In that, we were doing stream. We were just directly doing stream in to Power BI like that. So you can also stream it, or you can through the serving layer also do it. So as part of serving layer solution, we have analysis services in Azure. So Azure analysis services. Analysis services. Now these analysis services are basically the data cubes which we create. This is that data which we are pulling from this location, or maybe we are pulling from many other tables over there. As such, let's say various location, and data is getting pulled from various locations. And then finally, when you click in the Power BI, the data is actually coming from this particular data cube over there, or this particular data, which is in the serving layer, not on the warehouse. So one layer is extra over there called as serving. And when we work with warehouse, it will be there.
So that's the same, right? That's the so that's the same, right? The SSAS they call it, Azure SQL Analysis Services, OLAP Cube they call it. Yep. And is this also this OLAP Cube part of the Synapse? Then you can build a cube on top of Synapse and save it over there.
Yes.
Awesome.
So that offering is different. Like it's not. You can say that's analysis services, which is SSAS on-premise, and this is Synapse. They combine together. Like that.
So, Shivam, in the Synapse architecture, the data is loaded in a distributed manner, or it's just stored in a single block of storage?
So in Synapse, if we further think about it, this Synapse will be having two concepts inside it. One will be compute concept, and one concept will be of storage concept. So storage are always 60 nodes. So when I distribute my data will be distributed into 60 nodes as such. Compute is scalable because compute is expensive. So this you can scale between 1 and 60 like that. So if you want more performance, you can increase the compute and your data will be in 60 nodes like that, always like that, distributed.
But the data in the warehouse will be it will be consumable, right? From that I can generate the insights and I can do reporting from the Synapse.
Yes. So what runs over here? SQL queries run over there, normal SQL query. So you will run the SQL query. The SQL query will be broken in by the control node into 60 parts, and the 60, you can say 60 small queries are running in all the places, and we are getting one output back. So I can directly do reporting on top of Synapse. We can do it. So,
no further transformation is required once I load the data to Synapse, correct?
Yeah, you might be having the data in transformed manner. That's why you are doing it directly on top of it.
It's basically we used to store historical data there, correct?
Historical data.
Yeah.
OLAP.
OLAP, yeah.
Okay, so I think this is good enough. So check this out. Now, one more thing. I deployed it already, Cosmos DB. And this is Cosmos DB is that semi-structured data will be kept. Non-relational data location, extremely useful. There is one of its kind. So I deployed this before we started because it takes 10 minutes to deploy. So now inside this Cosmos DB, we basically have, you see this data explorer over here. We can, just give me 1 second. I have one query also written for you. I have it over here. So just hang in. What is happening? I'll explain once it starts happening. We are inserting some data over there. So some query is there which is running. Let it run. So in the meantime, so what is this Cosmos DB? Now here we have, so you see this container. Now in normal relational databases, we have a table. Table is there. So table in Cosmos DB is equal to container. So I'm creating, and database is database. So I'm creating one database right now. This is my demo DB, let's say, right? And then inside, and what is this throughput? Throughput over here is basically how much read write can I do per second. So 400 RU is given by default. I'm also happy with it. It means 400 KB per second in idle scenario I can read. right now from this, in every second 400 KB I can read. If I write, then write are always expensive, then we have to calculate it, but 400 is by default. I'm selecting it. So in relational databases, we have table. Here we have containers. So let's create the container. And this is, let's say this is a demo container. Demo container. And it's partitioning over there. So when my data inserts, if there is some particular partitioning which I want to do, so I'm just giving /id. I don't have any data which as such with me. I'm just saying that once my data comes, that data will be having one property called as id, and do the partitioning with id, or do it not, don't do it with id, which is pretty unique. Let's do it with category. Let's say category. Let's say maybe there is book category, cloth category, and so on and so forth. So the data is having that particular value over there, and when the data comes, do the partitioning with category. You guys might be aware of partitioning, so this is that, and I'm just saying okay after that. So my Synapse one database will come here, and one container inside that. So in the meantime, it comes up. Let me explain what I just did. So in normal relational databases, guys, how do we work with it? This is normal relational database. So there we have, let's say DB, and there is a table inside that, and table is having rows inside that. These are rows. So in Cosmos, we have the workspace, namespace or workspace first. We create this. This is workspace. So workspace is equal to that machine, you can say, in VM over here. Then database is database here. This is a database. So that remains same. DB is DB. Now that table is no longer table. It's called as collection. And this is, let's say, order collection or demo collection. And then we will have JSON documents over there. So those rows are now JSON documents, and we call them items as such. And this happens if I select SQL API mode of Cosmos, then this will happen. It will become a document database like that. And I can store my JSON documents, which is my semi-structured data, in as part of Cosmos DB. So my DB is ready, and DB is already got created. This one. This is the one. And how is that coming up? Actually, I ran that script. Then script is also running right now. So see, it's doing something. So what is that doing right now? It is inserting data into my Cosmos DB. So if I show you the one which I did from the script, it is having this container called as small. And if I click on item, these documents are getting inserted in real time right now. As we are speaking, they are getting inserted. So let's make it a little bigger. And check this out. If I click on any one of them, this is how document data is stored in Cosmos DB in JSON document like that. So some ID, title, category, list price, purchase price, and so on and so forth. Order number, who purchased this guy purchased it, and zip code, state, VA, street address, and so on and so forth. So semi-structured data, distributed database, Cosmos DB, and I can create multiple global endpoints. So if I click on this option over here, replicate data globally. Right now my endpoint is East US. I want my customers are also in, let's say, Central India. So I just click on it, and it got added on the right side, right? So let's say now my customers are in US and in India itself, both the location, or maybe my customers are also in UAE North. So I just click on 1, 2, 3, and now what do I want? Do I want multi-region write? If I say enable, all are master, all became master. So write can happen in all the location. If I disable it, it is only one master, other are read copies. So it's up to you. And once you do this, just say save after that. And now 3 endpoints globally will be available once this configuration finishes. And distributed database from scratch, like that got created. Any question which comes to mind, think it through and ask.
So my application should have a logic to use these 3 endpoints and write the data to them, right?
My application should understand how to do concurrency. Like should we lock the data when we write it, or should that is pessimistic concurrency, or should we do optimistic concurrency? So like when we write the data, then compare it. Like, is it data modified or not? So you can say 3 endpoints in the world. So then we have to, concurrency should be there. How do you develop an application? Yes, so it will be specific to distributed database.
Correct. And if I write in one location, it is going to be automatically replicated in other locations, right?
Yes.
Okay.
Like that. So this is what
Shivam, Shivam, how will we decide like we need to do a multi-region write or just we need to write in a single region and then get it replicated in the other two?
Now, for example, let's say if we think about a practical scenario, then multi-region write might be there. Why? Because my customers are in Japan. Let's say some customers are in UAE and some customers are in US or India. So then if you don't do multi-region write, then this happens. One is write and others are slave read copies. These are slave read copies. So then write will only happen in master. So latency will be huge. From India to Japan, latency will be there. UAE to Japan, latency will be there. So then you may go for multi-master in that scenario. And then think about concurrency, how will data will sync and so on and so forth, like this. So this depends on us, like what do we want to make, like that.
Okay.
This is Cosmos DB, distributed, multiple modes. Now it is really getting created. So it will take around next 10 minutes for it to finish. But these are 3 endpoints in the world now will come up, all are master.
Okay, sir. These like happen live replication, right? We cannot define any timeline.
One more time. These are
like these are happen live replication, right?
This is live replication. Live.
We can define timeline, or otherwise is by default.
This is by default real time. So real time replication. There is no delay over there. As fast as it can be, it's syncing right now.
Okay, sir. Thank you.
Okay, so guys, this is Cosmos DB, and we were inserting some data. So all the data got inserted, and 3 endpoints are coming globally as well. And this is basically how the look and feel of it. And so that's your data looking in JSON format. So it's only one of the mode of Cosmos. There are more details into it, but I think this is good enough right now. If you have any specific question, please ask. I'll explain that.
So Shivam, can we just load the data in a JSON format or in a semi-structured format, or we can also model the tables like we do in structured relational databases?
There is no table, document database. So
okay, just the document database.
Document database, schemaless. Now schema you can enforce afterwards, but there is no table concept. Table is not there. Like in relational databases, no table here.
So it's just a pure semi-structured and schema, basically a NoSQL database.
Non-relational and distributed globally also, global database.
Okay.
So Shivam, we spoke about for Cosmos DB, always there will be 3 replicas created of a same copy, right? Suppose at one location you have one Cosmos DB created, it will have by default 2 more copies created that will not be visible, but internally it is present for that particular location. But in this scenario, which you just explained, where we have 3 parallel copies, then what will happen in that case?
Okay, that was different. The one which I told you before was backup of SQL LRS. That was a different thing. The meaning of that was this, right? Here only 1 copy was there. We clicked, so now 2 more copies are there. So earlier what I told you was this, that Microsoft is having, let's say this is East US data center of East US region of Microsoft. So in every region we have a concept called as AZ. AZ means data center. So this is AZ1, this is AZ2, and AZ3 availability zones. So this is AZ availability zone over there, like this. So these are data centers. So then 3 copies will be in the same data center of backup in terms of SQL. So SQL backup will be there, but 3 copies in the same data center for redundancy purpose. Here it was literally one copy, but now I have 3 global endpoints because I clicked on it. So that was different.
Okay, I confused it. Okay, thank you.
Right. So, okay, so guys, notice this. Now I just have a couple of more slides left with me. Now, this is what I told in the whiteboard diagram as well. We can combine the stream processing and the batch processing. So data factory will get your data from on-premise. Maybe it is log file, media file, or some different type of data is there. Customer SaaS solution we can also pull data from. So if you have data in PayPal, Salesforce, and so on and so forth, we can pull it from there as well. So storage will be data lake. Ingestion pipelines can be data factory. We can do data preparation with data factory. Warehousing for OLAP, analytical processing. We can store our structured data for historical data in Synapse. And visualization can be with Power BI. You can use anything else also which comes to mind, Tableau or any other solution. Or you can go for Power BI, which is one of the good ones. So now, so this is basically what I had in terms of slide deck. And so I'll just take your questions now, and I'll tell you more about what type of questions will come in certification. And there are some other sessions also. Next weekend, we have more sessions, basically Power App. Then we have AI session will be the last one. And there is one more session which Nilesh is taking before that. So join us again for the next 3 weekends for other sessions as well. And what type of questions will come in your certification? Basically, you will have a very basic type of question, like what is relational data, what is non-relational, what is, let's say, what is structured, unstructured, what is semi-structured, is text file structured, or is it unstructured, is PDF structured, unstructured, so it's unstructured. So these type of questions will be there. And MCQs will be there, multiple choice questions, drag and drop type of questions will be there. Like they will give you the right answers. You can drag it and drop it. Total number of marks will be 1000. You have to get 700 marks. And basically, the entire content is of 8 hours. I have just given you 2 hours of overview of it. So you have to, you can say, revise further. Then only can you go for the certification. I will give you a couple of locations from where you have to learn further. And so notice this. So if I search for DP-900, and it's a pretty easy certification, don't worry, it's pretty easy, but DP-900 certification. So if I click on it and I go to DP-900 and I scroll down over here, then this is DP-900. And if I further scroll down, we will have these 4 things over there, like core concept of data, some relational data. So this is 5 modules over there. And this link, you can just Google up for this link. Just say DP-900 certification. And these 4 links are there for self-study. So if I go to the first link, this is 2 hours of self-study. So modules are there, like what is core data? Why do I need, what is the meaning of batch and stream processing? Roles and responsibilities of in the world of data. The relational data, non-relational data, data analytic concept, and so on and so forth. So 2 hours over here. Then 1.5 hours of Azure fundamental, what is relational data? Then again 46 minutes of non-relational data. And then again 2 hours of data fundamental. If you're doing for the first time, it will take you more time. This is for someone who maybe an expert into all this. So for me, it might take maybe some more time to do it. But the data factory and so on and so forth, all the things we discussed will be in these links. So just Google up for it, DP-900 certification. You will land on this page, and on this page, scroll down and find these links over there in the bottom. So, and you can also find me on LinkedIn. If you have any further question, just look for me, Shivam Sharma. On LinkedIn, you can find me. You can add me over there. And I'm always available for answering any question as such. So whatever comes to mind, please ask. And let me know your doubts or questions.
So one question. So with respect to the data flow that you used, which is you told instead of writing Python notebooks for transforming the data after EL, we have to do the T, right? We have to do the transformation. So for that, instead of writing Python notebooks, you told we can use the data flow, which is a GUI method. That is something similar to Informatica and Pentaho tools that we use in on-premise ETL, right?
That is
Hello?
correct. That is correct.
But my doubt is actually here in the on-premise we basically generally do ETL, not ELT. So how can I decide whether I need to do ETL or ELT? Any criteria as such based upon which I can decide that, sir?
So now notice this. Now check out my statement over here. So it's basically ELT or ETL is just the perspective of it. So in Data Factory, it will always be ELT part, but how does it really do it? So imagine you are getting your data from this location. So let's say this is my AWS maybe, and from there we are getting the data. So my first problem is that I have to get my data from these locations, maybe GCP. Maybe this is my customer's Azure portal, or maybe it's our Azure solution, but somewhere else in the world. Or maybe it is on-premises. So on-prem, right? So various type of data might be there, structured and unstructured, and we are pulling all this data from there. So the first problem is we have to extract this. So extract. So if you are really having your data from so many locations, the first thing I'll drop is this is my Data Factory pipeline. There I will have copy activities. So these are 4 copy activity for scenario. So they all will be extracting data. But once we extract it, we have to load it somewhere. So this in Azure, this data lake will become my staging location. So this is my stage location, and this is data lake. Data lake like that. So all the data, 4 files are coming into this data lake from those extract like that, like this. And once I write it here, this is the load part like that. So I didn't have any option to transform from these locations, imagine. So there is no transformation happening in middle over there. So now my data is loaded into the cloud, into maybe this location called as data lake, can be any other location as well. And this is acting like the staging part. So then after that, this all of this came. Now maybe it doesn't matter, do we use GUI? If I want to use GUI, then data flow like that. And what happens, GUI is little difficult to use in the sense, sometimes a 4 line of code is simpler to do. You will get a hang of it.
Correct.
You will get a hang of it. So you can use GUI if you want. That is totally fine. Or you can simply use any Spark notebook and so on and so forth. Just write 4 line of code. So then this is EL, and then my data. So T part is basically this is T part. Doesn't matter. Even if I use data flow, again the transformation is happening on Spark only. But the code part is now replaced by GUI. So one Spark cluster will be created on demand, even in GUI scenario. This is that Spark cluster. And then this is where the job is running. And this job is basically, you might have done this with Python, or you might have done the job with GUI. So, but it is running in this. So this is where the T comes into picture, transform part. So like this, in this manner. And then if we further think it through, so this sync became the source of my next step. And this might be writing the output somewhere else. So it is writing the output into this SQL database, let's say over here. So again, this is getting load. So if I change the perspective now, so now this is my extract going on again. This is extract, and this is transformation going on over here. And then it is going on load over there. So more like perspective also, like from where are we getting it? So this is where my extract, load, and then transform happened, because really on the fly we cannot magically do it. And this is where we again extracted, transformed, and loaded. So full pipelines can be created like that. So like this. This is this sync over here. Think it.
Got it, sir. Thank you.
Shivam, Praveen here. Good afternoon, Shivam. I have a question here. Hope you are doing good. So, see, there are companies have got this big data and analytics as one of the major use cases, and they also have data archiving as the use case. So, can the same data lake concepts and all the other things can be used for both your data lakes, which is your self-service BI portals and all the other things, plus your data archiving also, so that like both these capabilities are realized with the set of tools available in the data lakes, like the Spark and HDFS and all the combination you told. Have you seen such a scenario or a request?
Yes. So notice this. Now every functionality is available. So if I just take you back to my storage account, now let's say I click on any one of them and I click on this, and we should have some data. Now this is my file. This file is very big, but very small. But imagine it was very big or XYZ. I want to archive this. So we have now everything is integrated into one service. I can simply archive from here. So if I'm using something, it is hot data, frequently accessed data. So if I want to, if my data is cold, 30 days, I use once only, that type of data. So cold data. Or I want to archive for long-term archival, I just archive my data. So if I save this, it just went grayed out and it archived, and the cost also comes down. So in hot, we get discount on transactions as such, like how many times I read, write, discount will be on it. In cool, the discount will be on storage cost. In archival, dirt cheap. So it just got archived. So my customer's requirement can be answered with Azure services, whatever they are looking for, maybe hot data, cool location, hot location, or archival also along with it.
Yeah. Thanks, Shivam. Just one last question. So if it is archived, right, then later for some audit point of purposes, they wanted to retrieve some certain records based on a query or certain period of time, date time or something like that. Is it difficult to show the value realization from archive, or is there anything we need to do again?
Yeah, we need to convert it back. So you need to convert it back. So now, right now my data is very small. So even if I convert back, it will happen within a couple of minutes. It will convert back. But the SLA is there. SLA is 15 hours. So less than 15 hours, they will convert it.
Okay, so the archive needs to be converted into hot again in order to realize the value again to run your reports and all the other things.
Correct.
Okay, thank you so much.
Right.
Sir, one question. So they, in the use case that you told here, you are loading the data into data lake, right? Instead of that, I can load that into a blob storage in my storage account. I can do that,
yes,
right?
Yes.
Okay, sir. Thank you.
Okay, so data lake will only come into picture, guys, if big data is there, big data tool is there, or we are doing some sort of analytics with Spark or Hadoop. Then only go for data lake. Cost is also there. To have this no upper limit HDFS location, it costs us. And storage account is pretty dirt cheap, normal storage account. So if I don't have any big data requirement, I will not use data lake. I will just use storage account, which is 500 terabytes of box. I can create many more. So, but I will not use data lake, which is Hadoop file system.
Sir, one doubt, sir. In storage account, how the data is basically stored? It is stored in the object based, or it is block based?
So storage account is having one. So you see this circle, this is called as container, like this. And what is this container? Behind the scenes, it's object storage. So this is that object storage, object store. So if I upload this JPG over there, this picture, this JPG in that object store. So let me make that. So this red container is in you can say red color I'm making now. So this is my app1 container. Imagine this is called as app1. So this is that app1, and that JPG is now in the blob. So this is URI, metadata, and this is my blob binary large object. This is blob, and that picture which I had over there, this is that picture inside blob. This is that JPG, like this. And this is called as one object. That's your answer. So data in is stored as object, but where is data really? Data is in blob. This place, binary large object, like that. And this total thing is called as object storage.
Okay, sir, got it. And in the same way, we have other types like file storage and other things we have, right, under the storage account.
Yes, we also have file share, queues, and tables.
Okay, sir. And this object storage, which is blob, is exactly similar to S3 in AWS, right?
Yes. Yes.
Okay, sir. Got it. Thank you. Sir.
Correct.
Hello, sir. Sir, my question is, what is the difference between HD Insight and Synapse when we can use like either of the case choices?
Okay. So now that's they are sort of little different things. Check this out. So let me just make one last diagram. And so check this out, guys. We're also on time, so those who want to drop off can drop off, and we'll just drop off in some minutes. So just give me 2-3 minutes. Check this out. So in big data ecosystem, this is my Hadoop file system is the bottom in Azure, which is equal to Azure Data Lake. Then on top of this, we have Yarn in big data, Yarn, resource negotiator. On top of this, we have MapReduce. So this is MapReduce. And this is where we write the Java programs and so on and so forth. MapReduce programs, Java, Python, or C++, or Ruby programs we write over there. When we don't know the programming languages, we write Hive queries. So Facebook made that Hive queries. So Facebook created that. So we can write Hive. So these are SQL type queries like that. They convert into MapReduce and they run in the backend on big amount of data. So this is my big amount of data over here in data lake. Similarly, we also have a thing called as Pig. This is Pig, and Pig was made by Yahoo, and we use a language called as Pig Latin, which is more English type language. So English type query language is there. This HiveQL is basically SQL type query language. HiveQL we use over there. So now where Spark comes into picture, Spark is equivalent to MapReduce, and MapReduce is programming model, like how do we write mappers and reducers. So this is Spark over here. So now this Spark runs with Yarn and runs on big data. This is 100 times faster than Hadoop. So very useful. In Azure, we can create Spark in two things. We can create Databricks. Databricks, which is from a company called as Databricks, who did a tie-up with Azure. And they create Databricks cluster, the one which we created, and pretty simple to use, zero management Spark cluster. So this is zero management Spark cluster, like that. And so what is HD Insight? Now, just on a very loose terms, if we think it through, the difference between IaaS and PaaS, infrastructure as service gives us more control, but we get more control, but we have to do more management. And platform as service is where zero management happens or very less management happens. So Databricks Spark cluster will give me sort of zero management Spark functionalities. If I can also create HD Insight Spark cluster. So HD Insight Spark cluster, I will have more control. I have to really make it, and it will take more time to configure and so on and so forth, but same thing it does. So here I can create Spark again, and I can also create Hadoop type cluster. So in Azure, Spark is of two places. One is HD Insight, one is Databricks. Databricks is pretty popular because of zero management capability and to the point type of solution. What is Synapse? So first difference is this, that Databricks is different from HD Insight. It's really like IaaS versus PaaS. Don't tell that to your customers, just to understand, like that much of difference is there. Like totally controlling something versus, and then you do so many more tasks which are not pointing towards your transformation of data. And Databricks is zero management. So Synapse is a warehouse of, and it will have structured data over there. So this is my Synapse. So now in Synapse, I will have these, just to simplify, these SQL nodes are there. You see these nodes as such. So when I write a table over there, so this is a table I want to write over there, this table. So this table will be broken and will be written inside those nodes over there. So some bit of the table will be here, some part of the table will be here, some will be here, some will be there, and so on and so forth, like this. So, and there will be one concept called as control node. When the query comes, the query is broken into small pieces and it is running over there. It looks very similar to Hadoop, like divide and conquer technique, but this is a structured SQL warehouse. So this is SQL warehouse. And it does massive parallel processing, meaning parallel processing. But in the entire diagram, this is how they look and feel like. Now it is totally possible in Azure that you are reading and writing from it. That's totally fine. You can import, export like this, but your diagram should be looking something like that. Hopefully I didn't confuse you further and it got a little more clear. At least how does it differentiate? Any question, guys? Think it through.
Yes, sir. Thank you.
Okay, so it's already time, guys. It's 2:35, so we'll break now. And if you find me on LinkedIn, if you have any question, please ask. And join us back for next weekend session. If you have any queries, please ask.
Is this not there?
Sir, one question. So with this respect to this, the Databricks and HT Insights, these are actually used, these are Spark clusters which are used for transforming my data and I cannot store data on them. Am I right?
Correct.
And the Synapse is something where I am storing my historical data which I will be using for my reporting purposes, and I will give the data to my Power BI or to my BI tools.
Now there is one thing I want to just contradict that. Now there is one concept over here. There is a local file system. So answer is not exactly no. There is a local file system over there called as DBFS, Databricks file system. So I can load data over there in DBFS also if needed. But generally that depends. Like, do we want to do it or not? Normally your data will be in data lake and it will be decoupled from the compute part. So whenever I don't need the compute, I can deprovision the compute and my data is in data lake, which is dirt cheap versus the compute where the cost comes into picture. So it's a very good architecture where they have decoupled the compute from storage. And only when we need to run the queries, the compute will create automatically, query will run, and then we deprovision the compute. So that's your answer, that yes, it is possible. Generally, we don't do it.
I can store it in the compute itself, but since compute is costlier and storage is cheaper, it is better to have it separate, decoupled. That's what you're telling, right?
Correct.
It's something like on demand. I create Docker containers, and once I'm processing, I delete those Docker containers. Something similar to this.
And your images are in Docker Hub or maybe
correct.
AC. Yes.
Got your point, sir. Thank you.
Okay. So guys, let's break then. If you have any quick question, please ask, or let me know.
It was a wonderful session, sir. Thank you, sir.
Right. You guys are most welcome. And if you have further questions, please find me on LinkedIn to ask your questions, get certified. And the link from the link, learn more.